Alright, so we're going to use this video to practice drawing some tangents and working with tangents. They came up with a little bit in the last video about one of the reasons you want to try and have nice smooth graphs and that type of stuff is being able to find the slopes at certain points on curves. Not all graphs are straight lines, but still, since we want to be able to use the values from slopes, we want to look at how to actually get slopes from things which are not straight, or so different types of curves and that type of stuff. And of course, you want really smooth graphs for this type of thing. Remember, curve of best fit, make it nice and smooth so you can get nice, accurate tangents, or as accurate as possible. And we're just going to practice that a little bit here with a couple different graph situations. So here we got a couple graphs. We'll start with this. We're going to find the slope at x equals 4. So we want to draw some tangents for this, and then we can work with it and just get the slopes and that type of stuff. All right. So of course, the whole idea behind what we're doing here is we want to find the actual to find the tangents. We want to make tangents. We want to find tangents in order to get the slope at a point. Okay. So that's what we're trying to do. So for example, if this was a dt graph, something like this, well, the slope of a dt graph is the speed, of course. So it's a curve. We could find, well, there's no slope for the entire thing, but there's slopes all the way along the curve. So if we wanted the slope or the speed at any given location, we would try and, pick that location, find the slope at that point by using a tangent, and that's generally how this type of stuff works. So let's look at that a little bit first. Let's get rid of this for now. Let's get rid of this for now. And for this first one here, we're trying to find the slope at x equals 4. So really simple. I'm just going to start by going to x equals 4 on my graph. And we'll make it ideal, something like that. We'll say it's right around there, which makes things a little bit easier. So I want the slope at that location. Now, there's different ways people do this, different strategies people use for this. Really, it's about ruler and drawing lines and that type of stuff as best you can. I can use fancy schmancy computer stuff to do this. But what you're trying to do is you're trying to draw a line that will skim the curve at that location. And you only technically should only hit one point on the curve, and that's just that location. So maybe something like that. Okay, so that would be an approximate tangent at that location. Now, since you're drawing this typically with rulers and stuff, everybody's going to draw it a little bit differently, which is fine. But you just try and make it as symmetrical as you can. We talked about that a little bit. So when I look at this, I'll look a little bit this way. And I'll look a little bit this way, and I'll see how far the curvature is on each side. And the curvature is about the same. You don't want to go too far away from the point, but the amount of curvature from my critical location at x equals 4 to those two parts, the curvature is about the same. It's nice and symmetrical, so my tangent's probably pretty good. So now that I've drawn a tangent at that location, if I want to find the slope of that line, I just need to know 2 points. Now, try and keep the points as easy as you can. I'm just going to use this one right here. I mean, that's pretty easy. That would just be coordinates 4, 12. And then probably the other super easiest one to use would definitely be the x-intercept. That's super easy. So I'm going to use this one as well because then I can use the 0, and I know the 0 is going to be exact. And give or take, this probably looks like, well, everybody will draw this a little bit differently, but for me it looks like around 2.70 would be the coordinates of that point. So now that I've got 2 coordinates for that line, I can then just find the slope of the line. So this is where your good old change in y over change in x kicks in, rise over run, however you want to look at it. Doesn't really make too much of a difference. So between those 2 points from here to here, my rise was 12, and I went from 2.7 to 4, so my run would be around 1.3, so I just have to divide those two out. And if I do that, I get about around 9.2 would be my slope. So again, since everybody draws this a little bit differently, your slopes can be a little bit different, and that's perfectly fine. So hopefully, around 8 or 9 or 10, somewhere around there would be the approximate slope. So if this was a dt graph, so maybe it was a dt graph, and drew the tangent at t equals 4, the speed at that location would be about 9.2 meters per second, and this is generally what it's used for. So that would be, it's actually called the instantaneous speed. It would be called the speed at an instant, so that would be the instantaneous speed. but that is the slope at that point. And again, if we went to the beginning part down here, obviously if we drew a tangent down there, the slope would be really, really, really low. And of course, if you went up here, the slope would be really, really high. Well, that's not even part of the thing. So if we do that, if we did over here on the actual curve, there we go, it would be a little bit higher. So a little bit higher than 9. So maybe for me, it might be 10 or something like that. So anyway, so a little bit of give with your measurements. There's nothing wrong with that. With reading the points, there's nothing wrong with that. But hopefully you'll end up around the same tangent, relatively close. Looks like for me, it looks around 9. So we've got like 8, 9, or 10. If you got like 0.1, you probably flipped the calculation. But hopefully you didn't get like 2 or 3 or like 28 or something like that. So hopefully around there. Okay, so let's do the same type of thing for the second one. The second one here, we're looking for the slope at x equals 2. So that would be right around here. So that's where I want to draw my curve. When I often do this with rulers, on paper and stuff like that, what I'll often do is I would start with the ruler. I'll see if I can draw a ruler here. So maybe this is my ruler on my paper. And then what I will do is I will actually slide it on the paper this way and trying to, as it sort of incomes, I want the ruler to hit my little point right there, but I want it to hit symmetrical. So that's one of the common ways that I will actually do this type of thing, is put my ruler on paper, approach the curve from the outside, and then just move it nicely, just shift it left, shift it right a little bit, angle it differently, so I got the nice symmetry of the curves on either side. Okay, but let's get rid of this for now. There we go. Okay, so I want to draw my tangent at that location. So it would look something... Okay, let's start with this. See, that's not a good tangent right there. There's no way that's good. It's angled too far. You can see there's not symmetry in the curvature on either side of the dot. This isn't necessarily that good either. You don't really want it to be on the inside of the curve. What some people actually do when they draw their tangents is they'll actually do something like this. They'll actually have it touch both sides of the curve and then have sort of like a symmetrical curvature inside. I prefer to have it on the outside, maybe something like this. I like to have it something like that. So it's hitting my one point as close as I can, and I look just to the left, I look just to the right on either side of it. Maybe I'm looking maybe around here and around here, and I've got pretty symmetrical curvature on either side. So that's a pretty good tangent, I would say. All right, so I'll do the same thing we did before. Tangent's already drawn. Now I just want to take 2 points. It doesn't really matter which 2 points you want to use, but try and pick easy ones. You could use this one, but I would find this intercept right here and this intercept right here way easier. So I'm going to use those intercepts because I know the value of 0 for the intercept is, I know that's exact. I like that. So if I go my left one here, if I look at the coordinate for this one has a coordinate of about 0 and looks around, it's not quite 90, so maybe I'll say 88. And down here, it's just past 4, so maybe around 4.1 and 0, something like this. So again, I'll do my rise over run. The change in y is 88. Change in y over change in x. Change in y is around 88. My change in x is 4.1. So then I'll just divide those two out. And if I do that, I get around, well, it's around 21. Okay, now it is on its way down. I can see it's going, the line, my tangent is going down up. So instead of 21, I would actually just make that a negative 21 because I get to see it's a negative slope. So my slope around negative 21. Now again, everybody's going to draw this a little bit differently, but hopefully you end up with a slope around negative 20, maybe not negative 19, somewhere in the low mid 20s, maybe somewhere around there. It all depends on how you draw it, and the curve's already done for you, so that's kind of nice, but when you start doing this on labs or assignments or when you actually apply it, since people draw their curves differently, their tangents end up being different, and that's fine. We're just practicing actually doing the actual tangents themselves. So there we go. So we got a slope around negative 21 or so. Okay. All right, so let's try a couple more here. All right, so here we got something like this. And it says, find the slope of both curves at x equals 3. and then find the slope of both curves at x equals 7. I think I will just try and do, maybe I'll do x equals 3 and x equals 7 for the blue one, and just start with that for now. Okay, so I'm going to focus on the blue one for now. So if I'm going to do that, I'll try and visualize this as best I can. I want the slope of the blue one to x equals 3, so I'll go up from x equals 3, which looks like it'd be right about there. And I want to draw a tangent there, so as best I can. So your tangent will probably... tangent might look something a little further down. That's not too bad. Okay, your tangent might look something like that at x equals 3 for this one again. So I'll draw my tangent. Curvature just on either side, not too bad. Maybe angle it up a little bit higher up, but we're just practicing right now, so no big deal. Okay, so we got a tangent, so I just need the slope of that tangent. So again, I need to have a couple coordinates. For this one right here, it looks like around 3, maybe around 24, so this might be around 324. I like using my intercept because it's easy. It's really close to 15, maybe 0, maybe I'll say 15.5, maybe somewhere around there. Okay, so now I've got 2 points that I'm going to use. Use that point, and then I can find my tangent. So this is curve A. And we're doing this at x equals 3. If I do my delta y over my delta x, my change in y, well, it goes from 15.5 to 24. So that would be a difference of 8.5. So it went up 8.5, and it went from 0 to 3, so that's easy. So I'll just divide the 2 out. And if I divide the 2 out, I get approximately 2.8 for a slope. So at that point right there for curve A, hopefully the slope's around, looks like around maybe just under 3, somewhere around there. So hopefully you get somewhere close to that. Okay. All right. Well, let's do the exact same thing. Well, let's do x equals 3 at B as well. Why not? All right. So for x equals 3 at B, so I'm going to go up on B. That'd be right about there. I'll switch up the colors here. Let's use red. So I'm looking right there. All right, so I'll draw a tangent there as best I can. Oops, wrong tool. Line tool. All right, so let's try here. That's not good. Move around a little bit. All right. Okay, that's not too bad. A little more curvature actually would be nice, but not a little more. A little more straight up and down. Now, just looking at my 2 lines, the blue line that I drew and my orange line, they're almost parallel to each other, so I'm expecting those 2 slopes to actually be really similar to each other. So let's keep on going here. I'm going to need a couple points in order to find my slope. So I'll just use that point right there, and I'll use the intercept because it's easy. So looking over here, looks like around 3, maybe 13. Looks like around 313, and this looks like, we'll say, looks like around 0.4, somewhere around there. So I'm looking at curve B at x equals 3. My change in y over change in x. My change in y going from 4 to 13, which is 9, and it goes from 0 to 3. So something like this, and of course 9 divided by 3 is 3. Now this makes sense because my 2 lines were actually really close to being parallel to each other, so I'd expect similar slopes. So my first slope was 2.8, my second slope is 3, so they are almost parallel to each other in my calculation. So it's also a good indication I've probably been doing this correctly. Okay, so, and that's just more practice. So you do the same type of thing for line A and B for where lines A and B at x equals 7, do the same type of thing. Now you can see if you look actually at that one for a second, if I look at x equals 7 for B and x equals 7 for A, those 2 are not going to be parallel to each other. A is really flat, so I'd expect a really slow slope there. And B is a little bit steeper, not quite as steep as what we started with, so probably it's going to be less than 3 or should be less than 3. But the slope here at B should be higher than the slope at A. Okay, so anyway, so that's how sort of a tangents work and how you just draw tangents. You just draw them as best you can to be tangent to the curve. Look for relatively good symmetry on either side. It's a little actually hard to do on the computer here, but with a ruler it's actually easier. And then just look for the symmetry of the curvature on both sides. And again, nothing wrong with your answers being slightly different than mine, because people are going to draw them a little bit differently. You're going to see points a little bit differently, and that's just part of tangents. But that's generally how it works.